So hello everyone, and this week we start with a new chapter, which is wireless LANs. So in this chapter we are going to discuss about what are wireless LANs, what is their standard, and alright, so just an overview of the wireless LANs. Let me just give you an overview. In the recent years you might have seen that wireless LANs, we call them as WLANs, have come to occupy the place of the local area network market, and organizations, companies, they are finding that wireless local area networks, they are more useful or indispensable to the traditional wired LANs, because they can satisfy the requirements of mobility, relocation, coverage of the locations, and other things. So in this chapter we are going to discuss short concepts on the wireless LANs. So let's just start it. Wireless LANs. So wireless LANs means the transmission is the wireless medium. Wireless medium, which is the radio waves, microwaves, infrared waves. So this is the transmission medium. Until relatively recently, wireless LANs were little used. The reasons were because they were highly priced, but nowadays you can find they are cheaper also. They had low data rates, and they had certain safety concerns also, and they require the licensing requirements also. But now the licensing requirements are solved. So because all these reasons or all these constraints have been overcome, so now wireless LANs are used more and more, and they are more popular. Now the application areas where the wireless LANs are used, they are used in LAN extension, they are used in cross-building interconnect, they are used in nomadic access, and they are used in ad hoc networking. So we are going to talk about all these four application areas of the wireless LANs in detail: LAN extension, cross-building interconnect, nomadic access, and the ad hoc networking. Alright, so the first application area that we are going to talk about is the LAN extension. So let's understand what this figure is talking about. So this figure indicates a simple wireless LAN configuration that can be used in many environments. So if you see in this figure, there is a backbone wired LAN such as Ethernet. So this is a backbone wired LAN, which is the Ethernet. It supports servers, workstations, and it also has one or more bridges. If you see, it supports servers, it supports workstations, or it may have one or more bridges and routers to link with the other networks. Also, there is one control module that acts as a interface to the wireless LAN. So there is one control module. This is the control module. So this control module acts as an interface to the wireless LAN. Control module includes either a bridge or a router functionality to the link the wireless LAN to the backbone. So this control module can either be a bridge or it can be a router, and the purpose of this is to link the wireless LANs to the backbone Ethernet network. And also the control module contains some sort of the access control logic, such as polling or token passing scheme, to regulate the access from the end systems. Also, some of the end systems, they are the standalone devices. Now, if you see, these are the end systems. Alright, these are the end systems. These are the standalone devices, such as workstations, or it can be a server also. This is a standalone device, which is a server, such as a workstation or a server. Now, hubs or other modules, we have user modules. Hubs or other user modules. So we have the user modules also. If you see, these are all the user modules. Control a number of stations of a wired LAN, and they may also be a part of the wireless LAN configuration. So this is the control module, and these are all the user modules, and these are all the part of the wireless LAN configuration. So this can be referred to as a single cell wireless LAN. Because all the wireless end systems are within the range of a single control module. So if you see, all the systems or all the end devices, they are in a control of a single control module. That's why it is called as the single cell wireless LAN. We have another type which is multiple cell wireless LAN, which we are going to discuss in the next slide. So this is a single cell because all the devices or all the workstations or all the end systems, they are within the range of a single control module. That's why this is called as the single cell extension. Now this is an example of the multi-cell extension. So this is an example of the multiple cell wire LAN, or we call it as a multiple cell LAN extension. Why? Because if you see, there are multiple control modules. If you see, I have a control module over here, there is a control module here, there is a control module here. All these three control modules, they are connected to a single Ethernet backbone. So in this case, there are multiple control modules which are connected by a wired LAN. And each control module, so if you see in this area, each control module has some number of the user modules. It supports a number of wireless end systems within its transmission range. Similarly, this control module has certain user modules or the wireless end stations within its transmission range. And the same thing is about the third user module. I can take it of an example. For example, with an infrared LAN, the transmission is limited to a single room. So one cell is needed for each room in an office building that requires wireless supports. Just like in our college, if you see, we have wireless routers. There is a wireless router in the faculty area. Then there is a wireless router in the lab area. Then there is a wireless router in the classroom area. Then there is a wireless router in the upstairs. So all those are the independent control modules. So if you, for example, the wireless router which is in the lab control area, all the devices which are in the area of the lab, they can connect to that module. Similarly, the wireless router which is in the classrooms area, so if I take my device over there, my device can connect over there. So all the devices, user modules which are in the transmission range or the frequency range of a particular area, they can connect it. So our wireless LAN is an example of the multi-cell LAN extension, because at the backbone they are connected to the Ethernet switch, single Ethernet switch. Alright, now going ahead, the second use of the wireless LAN. If I go back, we are talking about the uses. The first use that we talked about is the LAN extension, in which we have talked about single cell wireless LAN and the multiple cell wireless LANs. Now the next use is cross building interconnect. So another use of wireless LAN technology is to connect LANs in a nearby buildings. Maybe they are wired or they are by wireless LANs. So they are connected by using bridges and routers. Alright, so in this case, point-to-point wireless link is used. Point-to-point wireless links will be used between two buildings. For example, two microwave or infrared transmitter receiver units can be placed on the rooftops of two buildings within the line of each other, and the devices so connected are typically bridges or the routers. So they connect bridges or the routers. This single point-to-point link is not a LAN, but it is usual to include this type of application under the wireless LANs. And this is an example, a two microwave or infrared transmitter which can be placed on the rooftops, and they are in the sight of each other. The devices that are used for this are bridges and the routers. Next use of wireless LAN is nomadic access. So nomadic access actually provides wireless link between a LAN hub and a mobile data terminal, which is equipped with an antenna. So it provides a connection between link LAN hub and a mobile data terminal, which has the wireless LAN properties. For example, connecting your laptop or a notepad computer, and such as a laptop or a computer or a notepad computer. And an example of such a connection is to enable an employee after you return from a trip to transfer the data from a personal portable computer to the server of the office. Nomadic access is also useful in the extended environment such as campus or the cluster of buildings or the business operating out of the cluster buildings. So in both these situations, users can move around with their laptops, or which we call it as the portable computers, and they can access the servers on a wired LAN from the various locations. So this is the third use of the wireless LAN. Going ahead, and the last use is about the ad hoc networking. So let's talk about ad hoc networking. What is an ad hoc network? So what is an ad hoc network? Ad hoc network is a temporary network, and it is a peer-to-peer network with no centralized server. This network is formed on demand basis. That means if you need something to share, you form a network, and after your task is done, you destroy the network. So this is a temporary network to meet some of the requirements. For example, a group of employees, each with a laptop, may link their computers in a temporary network just for a duration of the meeting. Another example is, for example, you connect even your mobile phones with your friends' mobile phones using a Bluetooth, and then you transfer the data. So that is an example of the ad hoc network. So ad hoc networks, they are formed on the demand basis. So the figure, if you see over here, it's an example of the ad hoc network. If you see, there is no centralized server, only the devices are interacting with each other. So the wireless LANs, this is a type of the ad hoc network which is just formed temporarily for the exchange of the data, and after our task is done, then it is destroyed. Alright, now if I go back. Okay, so let's go to the next slide where I will discuss the difference between the ad hoc network and the wireless LAN. Ad hoc network is a type of wireless LAN, but it is a LAN without any backbone, or not backbone, without any centralized server access. Alright, so considering both these figures, this ad hoc LAN and this infrastructure wireless figure. Now what is the difference between wireless LAN and ad hoc network? Now in case of wireless LAN, this is in case of wireless LAN, there is a stationary infrastructure consisting of one or more cells with a control module for each cell, and within a cell there may be number of stationary end systems. Stations can move from one cell to the another cell, but in case of ad hoc networks, there is no infrastructure. If you see in this case of wireless LAN, if you see, there is a access point, there is a access point, there is a wired LAN. So there is some backbone wired LAN, and there are some access points also. Now if my system is in the range of this router, then only I can connect to the internet. So if my station, for example, my system goes somewhere over here, I cannot connect to this router because the transmission range is not that much. Whereas in case of ad hoc networks, if you see this figure, there is no infrastructure or there is no centralized server. So there is no infrastructure required for the ad hoc network. Rather, a peer collection of the stations within the range of each other may dynamically connect themselves to form a temporary network. So ad hoc network is a temporary network, whereas wireless LAN is a permanent network. You cannot destroy it. Once you destroy, it will be permanently destroyed. Whereas ad hoc network is formed on the demand basis. When you need it, you just create a network, and when you don't need it, you destroy the network, and it's for a short term. Connecting your phones with the help of the Bluetooth is a very good example of ad hoc networking. Alright, so this was the difference between the wireless LAN and the ad hoc networks. Now let's talk about certain wireless LAN requirements. There are certain requirements which a wireless LAN should be able to meet. And what are these requirements? Let's just talk about. So the first requirement is throughput. Throughput means it should make efficient use of the medium. So it should make efficient use as possible of the wireless mediums to maximize its capacity. Second is number of nodes. So wireless LANs may need to support hundreds of nodes across the multiple cells. So it should be able to support multiple nodes across multiple cells. Third is connection to the backbone LAN. So use of control modules is required. So in most cases, interconnection with the stations on a wired backbone local area network is required. So for infrastructure wireless LANs, another difference between wireless LAN and ad hoc networks. Ad hoc networks are a category of the wireless LANs, but they are infrastructure-less wireless LANs, whereas this is called as infrastructure wireless LANs. These are also called as infrastructure-less wireless LANs because no infrastructure is required. Alright, so we were talking about the connection to the backbone LAN. So in case of wireless LAN, interconnection with the stations on a wired backbone is a must. And for infrastructure wireless LANs, this is easily done by the use of the control modules that connect both type of LAN. So it may also be needed for mobile users and the ad hoc wireless networks. Next is service area. So the coverage area for the wireless LANs should be in a range or in a diameter of 100 to 300 meters. Next is battery power consumptions, because wireless LANs work on the battery. So mobile workers, they use battery powered workstation, so that need to have a long battery life. So this requires that mobile nodes should monitor access points constantly or engage in a frequent handshakes with the base stations. So it must reduce power consumption while not in use. Next is transmission robustness and security. It should be reliable and it should be able to provide security. So unless properly designed, a wireless LAN may be specially vulnerable to the hackers or to the interference or to the network eavesdropping. That means someone can sniff your network, someone can steal your messages, someone can steal your data. So the design of a wireless LAN should allow reliable transmission even in a noisy environment and should provide some security features also. Next requirement for the wireless LANs is collocated network operation. That means there can be possible interference between the LANs or unauthorized access. So as wireless LANs are increasingly becoming popular, so it may be like a situation there may be when two or more wireless LANs operate in the same area or in some area of interference between the LANs is possible. So such interference may disrupt the normal operation of the wireless LANs, and it may allow unauthorized or the intruders to access your networks. Next is license-free operation, not having to secure a license for the frequency band used by the LAN. So users will prefer to buy and operate wireless LANs products without having to secure the license. So being a user, I don't need to buy a license. License is required for the company who is offering the wireless LANs. Next requirement is handoff or roaming. So the MAC protocol used in the wireless LAN should enable the mobile stations to move from one cell to the another cell. Like with the help of your mobile phones, I have like a station established over here in my area. When I transfer from one area to the another, still my phone can work. So that is because of the handoff and the roaming. Last requirement is dynamic configuration. So MAC addressing and network management aspects of the wireless LAN should permit addition, deletion, relocation of the end systems without causing any disturbance to the other systems. Alright, now let's talk about some wireless LAN categories, which are spread spectrum, OFDM LANs and infrared LANs. So wireless LANs are generally categorized according to the transmission technique that is used, and all current wireless LAN products, they fall in one of the following categories. So all the LANs, the wireless LANs which we have, they fall in one of the three categories. So the three categories are spread spectrum LAN, OFDM LANs, which is OFDM stands for orthogonal frequency division multiplexing, and the third one is the infrared LANs. Now what are these and where do they operate? Spread spectrum LAN. So this type of LAN makes use of the spread spectrum transmission technology, and these type of LANs operate in ISM, industrial, scientific and medical bands, and 2.4 gigahertz microwave band, so that no federal communication FCC licensing is required. Alright, next is OFDM LANs. As I told you, the full form of OFDM is orthogonal frequency division multiplexing. So this is a technology which is better or superior to the spread spectrum, and the devices with this technology are now common. Now the devices using OFDM LANs, they operate in either 2.4 gigahertz or 5 gigahertz band. The last one is the infrared LANs. An individual cell of an infrared LAN is limited to a single room. When we were discussing about the transmission media, I told you that infrared waves, they cannot penetrate the wall. That's why when you have a remote, you have to like pinpoint your remote towards the TV, and then you can change the channel. Or if you take the remote to other room, you cannot change the channel from the other room, right? So it is limited to a single room because infrared rays cannot penetrate the wall. So this type of LAN is not used much. Alright, now moving ahead. So let's talk about spread spectrum LAN configuration. Alright, so except for quite small offices, wireless LANs make use of multiple cell arrangement, as we have discussed in the previous slides, and adjacent cells make use of different center frequencies with the same band to avoid the interference. So within the given cell, the topology can be either hub or it can be peer-to-peer. So they can operate either as a hub topology or they can operate as a peer topology. So what happens in the hub topology? So in the hub topology, the hub is typically mounted on the ceiling and it is connected to the backbone wired LAN to provide the connectivity to the stations, and then it is attached to the wired LAN and to the stations that are part of the wireless LANs in the other cells. Hub may also control the access also, and the hub may also control the access by acting as a multi-point repeater, which we discussed before in the previous chapters, with the similar functionality to the Ethernet multi-port repeaters. And in this case, all the stations in the cell, they transmit only to the hub and they receive from the hub. Now we come to another type, which is, they may do automatic handoff. So what is automatic handoff? Automatic handoff, at any time a number of stations are dynamically assigned to given hub based on the closeness to the hub, and when the hub senses a weakening of the signal, it can automatically hand off to the nearest adjacent hub. This is called as automatic handoff. Now then there can be a peer-to-peer topology also. In peer-to-peer topology, as the name suggests, there is no hub and a MAC algorithm such as CSMA is used to control the access, and this topology is appropriate for the ad hoc LANs or the ad hoc networks. Alright, moving ahead. So let's just talk about the spectrum transmission range. Alright, so there are licensing requirements and there are licensing regulations. The licensing regulations, they differ between the country. The USA FCC Federal Communication, it allows the ISM band, and the spread spectrum systems can operate up to 1 watt. Very low power systems can operate up to 0.5 watts. But in the United States, 3 microwave bands have been set aside for the unlicensed spread spectrum use also. So, which is 915 megahertz band, 2.4 gigahertz band, and 5.8 gigahertz band. Whereas, in Europe, Japan and Middle East, 2.4 gigahertz band also operates in Japan, Europe and the Middle East. Alright, now let's talk about potential interference rules. So the potential for the interference must be considered. There can be the interference. So there are a number of devices that operate around 900 megahertz, which includes the cordless telephones, wireless microphones, and the amateur radio. There are few devices which operates at 2.4 gigahertz, and one of the common example is the microwave oven, which has a greater leakage of radiation with the increasing age. And the last one is there is little competition at the 5.8 gigahertz band, but higher the frequency band in general, it is the more expensive is the equipment. So these are some of the potentials for these are some of the spread spectrum issues with the wireless LANs. Alright, moving ahead, let's talk about the standards for the wireless LANs. Now there are IEEE 802. So this was the committee that was formed a new working group, and the committee was and the standard was IEEE 802.11, which was devoted to the wireless LANs, and the standard 802.3 was for the Ethernet, that means wired local area networks. So 802.11 standard was specifically set up for the wireless LANs. Alright, now what are the various standards for the wireless LANs? IEEE 802.11 is for the wireless LANs. Now there are further 11A, 11B, 11C which are the standard. You can just go through it, but not necessarily for the exams. Okay, now let's talk about some terminology related to the wireless LANs, which is very, very important. Access point. So access point is a station or some device that provides access to the distribution system via wireless medium. Basic service set. Basic service set, it's a set of stations which is controlled by a single function, coordination function. Coordination function is the logical function that finds out when a station operating within a basic service set is permitted to transmit and to receive the packet data units, which is PDU. Distribution system, it's a system which interconnects set of basic service set and integrated LANs, and it will form ESS. Although all these terminology we are going to study in detail in the next coming slides. So what is an ESS? It's a set of one or more interconnected basic service set and interconnected LAN which appear as a single basic service set. MAC PDU, so it's a unit of data exchange between two MAC entities using the services of the physical layer. MAC service data unit, it's an information that is delivered as a unit between the MAC users. Station, any device that contains IEEE 802.11 confirmation MAC and physical layer is a station. For example, my laptop is a station. Alright, So moving ahead, now we are going to talk, or we are going to discuss all these things in detail. So this is a general architecture of the IEEE 802.11 architecture. Okay, so let's discuss this architecture. Alright, I have certain terms over here which we have discussed now. STA stands for station, AP stands for access point, BSS is basic service set, and this is the distribution system and extended service set. Now let's understand the definition first of all. Access point, so which has a functionality and it provides access to the distribution system. So this provides the access of the internet to the distribution system via wireless medium. So this is an access point. Basic service set of stations controlled by a single access point. So if you see, there are 4 stations which are controlled by a single access point. So this forms the basic service set. We have another basic service sets there are 3 stations which are controlled by another access point. So this is a basic service set. Alright, next is distribution system. So a system used to interconnect a set of basic service set and integrated LANs to form an extended service. So if you see, both these access points or the basic service sets, they are connected to each other with the help of some transmission mediums or some technology. So this is called as distributed system. Now what is an extended service set? When multiple basic service sets, they are connected to each other they create an ESS. So what is an ESS? It's a set of one or more interconnected basic service set and the integrated LAN that appear as a single basic service set to the LLC layer. So extended service set is when the multiple basic service sets are combined together by the distribution system, that is called as the extended service set. Now let's understand this figure. The smallest block of the wireless LAN is the basic service set. So basic service set is the smallest block of the wireless LANs. What does it contain? It contains some workstations which are executing the same MAC protocol. Alright, now a basic service set may be isolated or it may be connected to the backbone by backbone distribution system through the access point. Now this basic service set, it can be isolated. If it is isolated or independent, that is called an ad hoc network. So I will come to that also. But if the basic service sets, they are connected to a backbone distribution system, for example in this case through an access point. So in this case the basic service sets, they are connected to the distribution system. They are connected to the distribution system through an access point. So distribution system connects the basic service sets and the integrated LAN also. So if you see, this is an integrated LAN. Alright, now what is the function of AP, access point? Access point works as a bridge or a router and a relay point. So in a basic service set, in this, client stations, these are all the stations, they do not communicate directly. So for example, if station 2 wants to send a message to station 4, so this message will not be sent directly. Rather, this message will be sent to access point first, then from the access point to the station 4. Similarly, when station 2 in this basic service set wants to send a message to station 6, so it will not be sent directly. Rather, the message will first be sent to the access point of this basic service set 1. Then from access point of basic service set 1 to the access point of basic service set 2 and then to the station 6. So they do not communicate directly. So the MAC frame is first sent to the AP and then from AP to the destination station. Similarly, a MAC frame from a station in a BSS to a remote station is sent from the local station to the AP and then it is relayed. So the distribution system can be a switch, it can be a wired network or it can be a wireless network. and the basic service set generally corresponds to what we call as a cell. So basic service set is sometimes called as a cell also. Now, when all the stations in the basic service set, when all the stations in this basic service set, they are mobile stations and they do not have any connection to other basic service set, that is called as independent basic service set. So when all these stations, they can move around and the basic service set do not have any connection to some other basic service set, this is called as independent basic service set. So independent basic service set is also called as independent basic service set is also called as ad hoc network. So in an independent basic service set, the stations communicate directly and there is no access point, as I told you while I was discussing the definition of the ad hoc network. Alright, so in this example we have certain stations, for example station 1, station 2, station 3, station 4, they belong to the basic service set this, and 5, 6 and 7 they belong to the other stations. So each station is within the wireless range of other stations within the same basic service set. It is also possible that two basic service sets overlap geographically so that a single station can participate in more than one basic service set. And there can be association between a station and a basic service set. It is dynamic. Stations may turn off and they may come in range. For example, just like your mobile networks or your mobile phones, when you roam from like a lab area to the faculty area, so your phones are roaming and they may switch from one one basic service set to the another basic service set. So extended service set. So this whole forms the extended service set. Extended service set connects two or more basic service set interconnection which is interconnected by the distributed system. Typically distribution system, it's a wired backbone LAN, but it can be any communication network. Also, access point is implemented as a part of station, and access point is where the logic within a station which provides all the networking functionalities. Also, in case of 802.11 architecture, a portal is used. If you see, this is a portal over here. The portal logic is implemented in a device such as bridge or a router, which is a part of the wired LAN, and this portal is attached to the distribution system. So this is the overall architecture of the wireless LANs. So all this I have explained it. So independent basic service set with no access point is called as ad hoc network. Alright, so all this I have explained it to you. Now let's talk about certain 802.11 services. So 802.11 defines a number of services that are to be provided by wireless LAN to provide the functionality. This table actually lists the key services and indicates the two ways to categorize them. We have association, authentication, deauthentication, disassociation, distribution, integration, MSDU delivery, privacy, and reassociation services. Alright, now the service provider can be either a station or for example, if you see over here the service provider. So the service provider can either be a station or it can be a distributed system. So in the so if you see over here, who is providing? Either it's a distribution system or it's a station. Station services are implemented in all the stations that have 802.11 functionality, and distribution services are provided between the basic service sets, and it may be implemented in access point or it may be implemented in special service device which may be attached to a distribution system. Alright, now if you see in the used to support, I have LAN access security, MSDU security. So 3 of the services are used to control IEEE 802.11 and LAN access, and 6 of the services are used to support the delivery of MAC services. 1, 2 and 3 and 6 are used to support MAC data units. So the MSDU is a block of data that is passed from MAC user to the MAC layer, and this is sometimes called as LLC-PDU, and if MAC is too large, it is transmitted by a single MAC frame. Alright, moving ahead. Now let's talk about distribution service and the integration service. The two services involved with the distribution of messages, they are the distribution and integration. So distribution is the primary service which is used by the stations to exchange the MAC frames when the frames must traverse the distribution system to get from one station in one basic service set to a station in the other basic set. So for example, if I go back in this figure, so if a frame has to be sent from station 2, this is what I just explained, to station 7, so the frame is sent to station 2 to station 1, which is the access point, and then AP gives the frame to the distribution. It will go from to the distribution service, which has the job of directing the frame, and then it will, from the distribution system, it will go to the station 5, which is the access point in the target basic service set. When the station 5 receives the frame, it forwards it to the station 7. So how this message is transported or how this message travels, we are not concerned with this. Alright, so if the stations are in the same BSS, distribution service logically goes through the single AP of the BSS. I already explained this to you. Next is the integration service. So integration service enables the transfer of data between a station on an IEEE 802.11 LAN and a station on an integrated IEEE 802.x LAN. The term integrate refers to the wired LAN which is physically connected to the distributed system and whose stations may be logically connected to the wireless LAN. So it enables the transfer of data between the wireless LAN stations and one of the integrated wired LAN station. So for example here, so from here to here, okay, from one of the station in the wireless LAN and to the station which is on the wired LAN. Alright, next we talk about association related services. So distribution, the main purpose of the MAC layer is to transfer the MSDUs between the MAC entities. So the distribution service requires information about stations within the extended service set and which is provided by the association related service. So stations must be associated before they start communicating. And before looking at the concept of association, we need to describe the concept of the mobility also. Alright. So, there are three types of services related to the association. Which are association, reassociation and disassociation. So association, it establishes the initial association between a station and access point, and before a station can transmit or receive frames, it must establish the association with the access point. Reassociation, it transfers an association to the another access point, so when it is moving from one basic service set to another. And disassociation means termination by station or access point. So a station should give this notification before leaving an ESS. For example, sometimes our phone switches off or there are weak signals, network, or when we are shutting down our device. Alright, so this is the association related service, and that's all about this chapter, and thank you so much.